Hello and welcome to the Titus Timeout podcast. I'm Matthew McLaurin, and today I'm going to discuss how active chill beams should be positioned in the room and in relation to one another. But before I start, I'd like to take a step back and just show a quick reminder of how active beams work. So let's draw up a cross section of a chilled beam. The basic parts of a chilled beam are a primary air plenum, nozzles which are stamped into the primary air plenum, a heat exchange coil, supply air slots, the induction grill, and finally, a case to hold it all together. An active beam works by ducting primary air from a central air handler to the beam's air connection. Nozzle stamped into the plenum creates small jets of air just above the coil. This induces room air through the coil where it can be cooled or heated. The induced room air mixes with the primary air jets and is pushed into the room via supply air slots. The important thing to note is that an active chill beam not only functions as a cooling and heating terminal unit, but also serves as an air diffuser and should be selected as such, giving due consideration to thermal comfort and throw direction. One question we are frequently asked is how should active beams be positioned at the perimeter of the building? Should they be installed parallel or perpendicular to the glazing? Well, linear beams such as the Titus CBAL models distribute their air just like slot diffusers, so generally speaking should be laid out in a similar fashion. Slots are usually run parallel to the glazing to throw the air directly down the glass to reduce the temperature differential between the glass and the room. This is especially important for good heating performance, as throwing warm air towards the glass prevents downdrafts, which may cause discomfort to the occupants at the perimeter of the building. Now, if the building is designed with perimeter convective heating so the chill beams are used for cooling only, then for most situations the beams will perform fine when they are positioned perpendicular to the glazing like this. Now let's look at how active beams should be located relative to each other and how other instructions might affect their performance. Beams are generally positioned at centers between 8 to 16 feet apart, depending on the loads of the building. If the room has just a single beam, it is often positioned parallel to the glazing or in the center of the room. Positioning the beam towards the glazing will allow the warm convective currents from the floor to be captured directly into the beam coil. Sometimes the ceiling grid layout forces the beams to be placed next to obstructions such as structural columns. In this case, we should use a one-way throw beam. One-way throw beams should also be used when the beam must be positioned immediately adjacent to a wall. Using one-way beams like this avoids short-circuiting, which is when the conditioned air from the beam slot is induced directly back into the heat exchange coil. Short-circuiting can also occur when two active chill beams are positioned too close together. Finally, when selecting and positioning the beams, we should consider the air velocities and mixed temperatures in the occupied zones, especially when designing the system to comply with ASHRAE Standard 55. The Titus chill beam selection software calculates the comfort data, which is expressed as velocity and temperature, which is a useful feature as you don't have to convert throw values to air velocities. So that's a quick overview of how to position your beams in a building. Don't forget to subscribe to our YouTube channels, and thanks for taking the time out with us.